Hey guys, and welcome back. So now we're going to take a look at the first use case of the flip fluid, where we have a specific area filled with water, and the idea is we want to create a pool next to this box and have the box splash into it. And let's see how that's set up. So the first thing is we're going to dive inside this geometry, and we need to create a dot network. I'm gonna call this flip sim. I'm gonna give it a red color. Inside, we're gonna create the all the parts needed for the sim to work. The first one is the flip solver. So flip solver. And the next thing is we need the flip object to plug into the first input. So flip object. And that's pretty much it. We're gonna need a gravity, and that's all. These are the three inputs. Now, in other solvers, like the fluids for the smoke solver, for example, you would have a second input here for the source. In this case, where we have a defined area that we're going to emit from, we're going to rely on a feature inside the flip object node itself. And we're going to set this to particle field and provide a set of points that defines the area of our pool or the water that we want to work with. So let's go back up and let's prepare the source. I'm going to create a box that encompasses this object and the surrounding of it. So we'll make something bigger. And to create this flip tank input, we're going to use an ocean wave node. We're going to use ocean source. The name doesn't really reflect all the use cases for this, but this node does a lot more than just ocean source. And we're going to set this to a flat tank. Okay. And you can see already it's filled with water. Let's template the box. And I'm going to move this a bit up. And we're going to make it bigger to give it more room so that when we have a splash, it gets something to interact with. Now this domain is very, very important to be careful of, because the more data we input, the bigger this is going to be, the bigger the domain of the volume sim we're going to have, and that means more voxels basically. Okay, so there's also the option to create a narrowband particle. In this case, we're not going to use that. I'll talk about it in later project once we understand the workflow properly and when to use it. And for now, I'm going to link this particle separation. I'm going to right click here and let's create a null. Call this out flip source. And if we middle click, we're going to see just particles or points. So that's our input. If we dive inside the flip sim, we're going to link that source here. So let's do that. Out flip source. And I'm going to change the visual, under the guide, under particles. Right now it's showing them as sprites. I'm not going to use sprites. I'm going to change them to particles. So we get this viewer. And let's go back here. So that's set. The next thing is to set the domain. Because there is a fluid motion, a smoke sim inside this, we need to define the domain. And we don't have to exceed this region, because that's where we want the sim to be. So I'm gonna make a floating copy of this, and let's pin it here. And let's go back inside the solver and link these two guys. So the size is going to match this, and then the center is going to be the same as this. Okay. And if we hit play, it should not fall. So let's set few things. Inside the flip object, right now the boundaries are not defined, so everything will fall. I'm gonna tick on closed boundaries and untick the positive Y, because we want the splash not to bounce if it hits this this region. We want it to continue, but everywhere else we want it to bounce. Now the domain is not set. It doesn't look the same, so let's check why is this happening. Could be that, yeah, we have a transform. So here I'm gonna simply zero out all the transforms on this object, and that should fix the issue. Okay, I think I have a viewport issue, so let me close this one and open. Yeah, it had a leftover ghost particles from the previous test, so now everything is working. And let's hit play. Nothing should, I mean, we're gonna see a little bit of movement, but everything should stay where it is, because we have collisions everywhere. Now the next thing is to add the box and have it interact with this. So to do that, we need to first create the collision geometry, or prepare the geometry for use in DOPS. And for that, we're gonna need to convert. The best way, actually, let's do it. Let's create an out collision geo. And let's dive inside. I'm going to create a static object. Now, obviously, the name here says it's a static object, but it doesn't mean it has to be static. It just means that the solver itself is not going to interact with this data, but it's not going to change this data. Okay, but we're going to we can update it every frame, which will make it dynamic, basically. So let's connect this guy. Swap path. Now we have our geometry imported. Let's hit play. Nothing is happening, and the reason for that is because the points are changing every frame, but this node only imports it at the first frame, at the creation frame. Basically, we need to tick on use deforming geometry to update the points every frame. So if we hit play, you can see everything is working as expected, and we have our nice splash. Cool. Let's go up on to move the box out of the water for the first frame. And if we dive inside here, it's very the way DOPS work is it tries to create a volume representation of whatever geometry we feed it. And these methods are not great. Most of the time we don't get the volume representation that we need to get proper collision. So if I tick on view collision guide and disable the geometry, see here it did a great job, and as I play through, you see the box is still doing a pretty good job. But if we had anything complex, it's not going to work. This method is not going to work, and the best workflow is to create this data in SOPs, and the way to do that is using VDB from polygons. So we're gonna simply create our own volume representation, and this has to be a distance VDB, an SDF basically. And if we play through, this looks like geometry right now, but it's actually a volume data. Okay, it's made of voxels, and then we're gonna tell DOPS to simply use this and not have to compute its own VDB volume representation. So let's go up, let's copy this path. If we hit Control C now in Houdini 17, it copies the path to the node itself. So I'm going to change this to volume sample, and here I'm going to paste the path. And you can see now we have our own volume representation being fed in. Let's turn the collision preview and let's hit play, and everything is working. Let's wait for the splash to hit. You can see it's continuing through, but then if it hits this area, it's going to bounce on that wall. Okay, so one thing that I still haven't done yet is this particle separation. The main two controls for the settings or the resolution of the sim is the particle separation and the grid scale. The grid scale is the resolution of the volume. The lower this number, the higher the resolution of the volume. So let's play through. Let's go to frame 24 and middle click on this. You see we have voxel data. This is the volume sim that is happening inside the flip. You can see here it's very low res. That's why the sim is quite fast. So we can keep the same points but increase the resolution of the grid scale of the fluid sim inside the solver. And so actually from now on I'm gonna call this a smoke sim. The term may not be necessarily correct, but this is what we will refer to the fluid like sim, the smoke like sim inside the flip solver. Okay, anything that is voxel based, we're going to call that a smoke sim. And so this smoke sim resolution is quite low, but say we have, for example, 5 million points and we're happy with 5 millions. We don't want to increase the number of points, which is driven by the particle separation. We can increase the detail of the sim by lowering the grid scale. This will drastically affect the sim time, but will not increase the number of points, because if, say, that's how much we can handle, we can keep that, but we can increase the details that is hugely driven by the smoke sim internal to the flip solver. So if I go to here, you can see we have 38,000 voxels. I'm going to set this to 1.75 and do another sim. It's obviously going to be slower. Let's wait for frame 24. If we middle click, it's 59,000 now. Okay, so if we keep increasing this, we can get this to be a really high res sim, even though we don't have enough points here. But you can see already there is more details now. But we obviously need to have a reasonable relation between these two to capture all the information needed to represent the detail in the voxels. And that's gonna come from the particle separation. To start with, we're gonna keep this at 2 and try to get a reasonable particle count depending on the scale of the sim. I would say we should aim for something between 2 to 5 million to start with, and then we can increase the number of points if we can, or based on if our machines can handle that, and or if we need more details. We should also consider lowering this to 175, but not lower, because the sim time is going to go really high, like probably going to double, even if we have the same particle count. So we have to be very, very careful with this guy. Okay, so the next thing is we need to, the particle separation, if we set this to whatever number now, it's not going to do anything. And what we need to do is we need to link this guy to the input. If we go back to the ocean source, you see there is a particle separation here. I'm going to paste relative that, and now if we change it, it's going to go back in subs and reseed the number of points. So let's set this to 0.4. Now we have 1.4 million, and we're going to keep this to 2, and let's hit play. And now we have a lot more details to work with. Okay, let's go back up, and I'm going to do one more thing. I'm gonna lower the thickness of this to have less points. Maybe let's increase this a bit more. I'm gonna move the box here, just to have less points. And that's pretty much it for the initial sim. Yeah, I wanted to have a smaller splash basically. Cool. So in the next video, we're going to see how to import the sim in SOPs and what kind of data we need to cache to disk. So we'll continue that in the next video. Thank you guys for watching, and see you in a bit.